Hi everyone, my name is Hank Venema. I'm the CEO and Senior Engineer at Strategic Systems Engineering. We're an engineering consulting and R&D company based here in Winnipeg, Manitoba, and we focus on municipal, watershed, and water resources projects. We've been engaged by the Red River Basin Commission and its partners to review the tools and software available for you, municipalities, watershed districts, to get the most use out of this major investment in LiDAR data. LiDAR is a great asset, and it will help you understand your risk, understand how your assets are exposed to risk, and how to protect and create value your citizens and your tax base. So let's get started with the discussion. There are many LiDAR software applications out there. The tool that we like for processing the data is called QGIS. It's a high quality, free, open source geographic information system, which you've often heard referred to as just GIS. There are other GISs out there, including Esri's product, ArcGIS, which is a very well-known program used by a lot of people. It is excellent. If you have it, we encourage you to use it. It also is proprietary, which means you have to pay for licenses. If you don't want to do that, we recommend QGIS, which is free and offers a huge amount of functionality. So for this video, we'll showcase QGIS. You can download QGIS from QGIS.org. You can find the link to the website in the description of this video. Downloading the program is easy. Select the option for Windows, Mac OS, or Linux, depending on the computer you have in your office. There is a tablet version that can use, but it does not have the functionality of a full GIS that's available on the other platforms. So remember that. QGIS can be used to look at, edit, and process essentially any geospatial data, including LiDAR. You can use it to visualize the geolocation of specific assets. You can store the relevant information, the attributes associated with individual assets. For example, the size of a particular culvert, its coordinates, its condition, good, excellent, damaged, whatever. You can record those attributes of the specific assets within the GIS. You can import culvert or wellhead locations. You can import features such as tree inventories straight from Excel spreadsheets. You can also add layers to show different land classes. You can display road and railway locations, even building information. There's a lot of free information about building information that's available now. So basically, GIS is a way to store and visualize large amounts of georeferenced location data. GIS can be leveraged to manage your LiDAR data. In fact, what you're likely going to be using is not the LiDAR data directly, but it's the digital elevation models which are derived from the LiDAR. That's what's published on Manitoba Land Inventory database. So if you go to the website, GeoManitoba website, Manitoba Land Initiative, and you download the digital elevation model for your region, that will be based on LiDAR. So it's not the original data that's been acquired from the aircraft. It's been processed to give you a very high resolution digital elevation model. That's what you'll be working with. The ability to add the location and the size, for example, of culverts to your digital elevation model within a GIS is key to a lot of municipal risk assessment. So the idea is that culverts connect water from one side of a road to another. And you need to represent those features in your digital elevation model. The LiDAR, when it's captured by the aircraft, can't see the culverts, but knowing where the culverts are is really fundamental to understanding how water is going to flow in your area. So what we normally do is we get that inventory of culvert locations and we burn them in to this digital elevation model, this high resolution digital elevation model, which comes from the LiDAR. The process is called hydroconditioning, and it's done within a GIS, and it can be done really efficiently nowadays. We'll discuss a little bit more about this process in later videos in this series. QGIS has a pretty user-friendly interface to view your data and maps. In the header, you can open and save a project under File and add features or layers under Create. This shows all of your shortcuts to QGIS tools such as Measure and your Edit button. The panel on the left side shows all of the layers of data that are in your project. As we go, you will see how we add layers with different types of features. Double-clicking on these layers opens a window where you can edit the attributes of those layers. LiDAR-based digital elevation models look like this in QGIS. They're black and white and kind of swirly and cloud-like. They default as showing the points of low elevation in black relative to the rest of the area. Lighter or white areas are at higher elevation. Without much experience looking at this kind of data, it may not mean much. It may not look like much of anything, but you can alter the visual representation by recoloring, changing the contrast, making it more or less transparent. And this can help clarify what you're looking at, what the data is telling you. To add some geographic context to where the LiDAR is, you can add a base layer of OpenStreetMaps or Google or Bing satellite. This can be very useful for providing context to where your LiDAR has been acquired. Sometimes making the LiDAR layer transparent may be helpful. You can also add all of the other kinds of geospatial data into your digital elevation models. You can integrate other georeferenced culvert inventories, wellhead locations, and or roads, for example, and look at how these features tie into the topography that we get from the digital elevation model. Points and lines are shapefiles in QGIS, and these then can be draped over the digital elevation model that comes from the LiDAR. You can also add other features included in polygon shapefiles, such as buildings. And this is a really interesting new data asset. Almost all buildings in Canada are now included in an open buildings database that Microsoft's made available. You can open this buildings database as a polygon shapefile and then drape where those buildings are located over the digital elevation model. So you can see what buildings are located at high elevations and what buildings are located at low elevations. All of this is very helpful for contextualizing what information the LiDAR provides for your region. You can maintain an inventory of different kinds of geospatial data assets. You can create maps and reports to engage with stakeholders that explain where different assets, where buildings are, where roads are, where culverts are. So please stay tuned for a deeper dive into the many ways LiDAR data can be used for improving climate resilience in your region.